that day's data or that week's data. But once it starts to age out a little bit, it goes dark. And that kind of sort of dark data concept is something that is starting to be an industry term.
Welcome to another episode of the Mapscaping podcast. My name is Daniel, and this is a podcast for the geospatial community. My guest on the show today is Kirk Marple. Kirk is the founder of Unstructured Data, and today on the podcast we're talking about unstructured data. But we cover a few other sort of interesting concepts along the way. So Kirk is going to introduce us to the idea of first, second, and third order metadata. We'll touch briefly on edge computing and knowledge graphs. Just before we get started, I want to say a big thank you to Lizzie, who is one of the brand new supporters of this podcast on Patreon, and of course to all the other people that are supporting this podcast via Patreon. If that's something you might be interested in, you'll find a link to the Mapscaping Patreon account in the show notes of this podcast episode. Hi Kirk, welcome to the podcast. You are the founder and CEO of something called Unstructured Data, and today I'd really like to talk with you about unstructured data. But before we do that, can you just introduce yourself to us, please? Let us know who you are, how you got involved in geospatial.
Yeah, for sure. Yeah, Kirk Marple. I founded Unstructured Data. Have been a long time software developer, and actually just remembered yesterday that I've been dealing with geospatial data back even from my first job, dealing with maps on laser discs. It goes back that far. So I've been more in the media space, so media software space, I would guess I consider, but I dabbled time to time in geospatial and now a bit more focused on it.
Well, I think we'll end up coming back to that later on, to your experience with the media space. But let's start here. Tell me what unstructured data is for you.
For us, it's really, everything. From imagery, audio, but also 3D, geometry, point clouds, as well as documents and emails. So it's a broad set of data. I came from the video space and media space, and we would just call them files. File-based workflows. But for us, it's really a broad set of file-based.
Okay, so every file has a really well-defined structure. Why do you call it unstructured data? Because I think if it's in a file, it's in this perfect little container that we all know that there's probably open standards around, or might be open standards around. Why is it unstructured?
No, it's a great point. I think it's a marketing thing, just to differentiate. The kind of structured modern data stack world from everything else. I do think it's a bit of a misnomer because essentially a lot of what we do is parse files. There's a known sort of schema or file format in all of these file types, and I've been dealing with those since TIFF files and fax files back in the day. So there's always a structure there, but I think for a lot of people, they see a document or they see an image and they're kind of looking at the content. They're not thinking about the bits on disk. So I do agree. I think it's a bit of a misnomer.
Where does metadata play into this idea of unstructured data? Can I have structured data without metadata?
It's interesting, or unstructured data without metadata. I think with structured data, I think a lot of what you're seeing these days is people adding metadata for data discovery tools around databases and things. I think in the unstructured space, the metadata is often there, and that's a bit more of a solved problem where there's EXIF data in images, or there's XMP, or there's Dublin Core, and that's a lot of where we start. We kind of have that first order metadata that's in the files is really what we start with, and we parse that out and we use that to kind of figure out what to do next.
Okay, so what is first order metadata for you?
That's sort of my own terminology, but it's the EXIF metadata. It's the data that you would be in the header of a file. It's if all you get is the file and you can't read the document. You don't know what the image is of. It's the bare minimum of metadata that we could get out of a file is kind of what we call it internally.
So when I think about data that's sort of embedded in a file like that, and then I think about geospatial data, does that make geospatial data sort of less unstructured because it has that other extra bit, like that geography attached to it?
Yeah, because commonly in, say, EXIF metadata, there's actually, you can get not just GPS location, often like from a phone image or a drone image, but there's even things, your speed, your acceleration. They're now putting a lot more information and context into the files themselves. So there is a lot of structure, even, for geotiffs and different things like that. You can definitely get a ton of context from a single file just from the metadata.
In our pre-interview, you talked about this concept of first order, second order, third order metadata. Can you mentioned a little bit before how you describe first order, but could you walk us through that again, please? I think it'd be really helpful for the rest of the conversation.
Yeah, and this is sort of a concept that I've just to sort of structure our thought and internally on how we look at the data that we're dealing with. I mean, I've been talking about or kind of considering the first order metadata is really, I mean, you open a file, you can get file headers. There's data there without doing much else, and we kind of call that first order metadata. So that would be like your EXIF or your XMP metadata in a file. And then second order is okay. Let's start actually reading the data in the file. So there's a document, there's an image, and that would be something like doing object detection on an image. I mean, seeing what's in the image and getting maybe bounding boxes of tagged bounding boxes, or say a document getting terms that are found. And so we could call that second order metadata. But then third order metadata is really more inferences of okay, I'm looking at, let's say, a conveyor belt in a picture. So someone's walking around on their maintenance route. They took an iPhone image that has EXIF metadata in it. They run it through a computer vision algorithm. You can see the conveyor belt. But then third order metadata would be that conveyor belt is actually linked in an SAP database somewhere. And so there's that contextualization, which could just come from inferring across a whole bunch of images or a bunch of data. And so we can call that third order metadata. That's really, I mean, that's when you start to get into machine learning and you start to get into more complex inference. And that could be something where we now know this is an image of this piece of equipment or this physical asset that is something that a customer has maybe in another database somewhere. So creating that edge essentially, and we think in knowledge graphs, so everything is kind of an edge connecting something to something. Creating those edges to us is kind of that third order method.
Is there any limit to sort of how far we could spider out from, first order metadata, to second order to third order? Could this essentially just carry on and on and on depending on our compute capabilities?
Yeah, I mean it's not that different from like what Google's doing with their knowledge graph for the web or other companies, but I mean theoretically you could essentially create a web spider. I know we talked about this in the pre-call, but it's I mean I was doing this for podcasts where you have an RSS feed that has MP3 files referenced in it. There's basically terms that are spoken that you can basically be that second order metadata, and then you could relate, say, the show notes from that RSS feed and start spidering out links and providing more and more context. And really, that data enrichment is kind of recursive. I mean, you can continue on and get more and more data. Really, as long as you can sort of find a link or something to connect to, it's theoretically kind of infinite.
So again, thinking about geospatial data with that geography element to it, would you ever use that as well? So, okay, this data, the bounding box of this data is here. So let's say in that object detection stage, you identified there was some pipes. So immediately okay, the pipes are here in the world, for example, or you have a rough idea where they are and start making inferences from there or building relationships from there as well.
Exactly, and that's actually something we're working on right now, and it's something we haven't finished yet. But really, and say you're looking at pipes, and from the drone metadata, basically that camera view, that camera frustum of what you're looking at. You can project that onto the real world, figure out essentially a geofence of okay, here I know this pipe is in this general region. And then what you could do is sort of cross-reference that and search that against a database to say, well, where are my pipes in this region? And do sort of a database lookup and try and identify, okay, is this pipe A or pipe B? And that's where things get really interesting because then you can start creating those links to say, okay, show me all the images of this pipe. And before, I mean, currently humans have to do that. You have to create those relationships of, oh, I'm taking a picture of this pipe. I know it's this pipe. But what if you could use machine learning and kind of this knowledge graph approach to say, automatically link those things together? And then you can kind of pivot on any piece of equipment and say, hey, show me all the images of this pipe in the last 30 days. And then those kind of connections have already been created for you.
So you talked about a human being in the loop before. Is a human not in the loop already, even though you have this process in place? I mean, I'm thinking about the object detection side of it. Is there not someone labeling images saying, oh, this is a pipe, this is a boat, this is a house? How are you solving that problem?
Yeah, I mean, there always has to be a human in the loop at some point, typically for the model training, but also for kind of that review and approval step. So you may have, I mean, someone has to create a model for a pipe, and so you have to have that sample data, that training data to start with that's labeled. And so there is I mean, a definitely a good amount of work that has to go on to get to that level. But once you can start to, I mean, hopefully have some commodity type models that are good enough. I mean, they may not be specific to your environment, but they've been trained on enough data that they can find pipes in a similar environment. That's really a one starting point. And then really also the review and approval of, okay, what it found wasn't really a pipe. It was a gas hose or something like that. And so you have to reject that data and then go back and continually train the model, tell it saying that the data wasn't that good.
You talked about this idea of commodity object detection, and I remember from a previous conversation you talked about Azure feature detection.
Yeah.
Is that what you're talking about? And if it is, could you describe to us what this is and how it works?
Yeah, so computer vision has commoditized a lot over the last several years. And so there are cloud services from Azure, from AWS, and from third party vendors that you can either get a model off the shelf, like Azure Cognitive Services Vision we use, where they just have a model. It's just an API. You just call it, you give it an image, they give you data back, that essentially metadata back that they gather out of that image. But then you can also go to some of these more no code type services to build a model. And that's where you may have, say, 100 images, 300 images, you do the annotation, and then they do everything else. They do all the heavy lifting to train the model, build the model, deploy the model. Or you can, if you have a data science team, you could do this all just via code. I mean, you might go right to the metal, I mean, and write Python code and do all this yourself. So there's kind of a real big sort of swath of different types of computer vision that you can do, from sort of easy to hard, but they all give you some level of detail about your images.
This is awesome. So it sounds like I can take my images, send it off to this Azure feature detection service via an API and say, tell me what's in the image, and it'll say pipe, bucket, house, whatever it is that it can identify, and send it back to me as a labeled image. Am I understanding that right?
Exactly. I mean, the downside of that is the models are trained somewhat generically, and that's what we found is you run Azure Cognitive Services. I mean, say on a drone image, and it'll find things like it'll call it aerial, and maybe it'll say outdoor, and maybe it'll say building. But honestly, I mean, it's somewhat useful for filtering, but it's not useful for identifying your specific things in the real world that you care about. And so that's why we kind of look at, you're going to have, and I think the common term is kind of an ensemble of models where you may have sort of this rough cut model that says, hey, I have a building. But if you find a building, on the images you find a building, you might want to run another model and then say, okay, go find me, I mean, differentiate sheds from garages or something. And that could be something where then you have a more tuned model. And really, then you can kind of build up this kind of layering of different models to get to the specific things that you want to deal with. So it's really, I mean, there's not one model to serve all, I think, is really the big point. And but we do see that, I mean, more models are really going to be the norm than less. I mean, the tooling is really evolving to make that possible.
That is really interesting. So this was actually going to be one of my next questions, was going to be around ontology. You sort of hinted at it there, I think, with, if you found a house, go and look for these other things. And also this sort of, parent-child relationship. Exactly. So you found a house, we can make some assumptions. Maybe it's time to run the window model or the door model or the something else. Is that the way I'm supposed to understand this? That this is perhaps what the future of object detection looks like?
That's the way I see it. I mean, I think it also helps in cost management, because it costs, I mean, a little bit. I mean, probably like a few cents to run each model. And so, I mean, say a drone flight, you're flying a drone over an outdoor area. Maybe only 10% of the data has buildings in it. So you don't want to run the window detection model on those 90%. So you want to sort of carve out. I always kind of use this buildings. I mean, smaller haystacks for bigger haystacks. And so as long as you can start to carve down the size of the data you're running it on, you can optimize the cost and performance. I mean, they go hand in hand.
So we've been talking about images for a little while now, because I think they're an almost endless source of unstructured data. We're creating more and more of them, and we need to find out what's in the images and create information from that. But earlier on, you talked about you used to do something with podcasts and sort of spider out and create a knowledge graph of podcasts. And I'm wondering about sentiment data as well, because data comes in many forms, as we've talked about. Can you read through documents and create sentiment? Like, what is this document saying? What is the feeling in it? Like, and sort of build and add that to your knowledge graph. Is stuff like that possible?
Yeah, and that's where it gets really interesting. I mean, it's really about that context, and what we really talk about is contextualizing the data that you're capturing to sort of real world entities, which are like people, places, and things. And yeah, I mean, the project I had worked on a few years ago, which was kind of the start of what ended up being my company, was taking podcast feeds, analyzing them for entities. So topics discussed, people, I mean, different organizations, companies, and then spidering out and creating those links to say, okay, this podcast discussed geospatial data, it discussed Python. Here are the people that were on it. Here are companies that were name dropped during the podcast. And what you essentially can do then is find those edges and say, well, hey, find me, and this, you can use it for discovery, data discovery then of, well, find me other podcasts that had this topic and maybe this co-host or this guest, and but then the show notes become a source of value where those for the podcasts that actually have good show notes, there's a bunch of links, and once you can start to, the other interesting part is, hey, I mean, what other data can we gather from the linked entities on the show notes or the linked documents, HTML documents, and start to create commonality from that as well. And that's where we started to see a lot of the value. And there was so much data. Essentially, I had to build like a web spider to do that, where it just would continually start pulling in the data, reading the document, doing entity analysis, coming up with a list of links that it found in the document, and then spidering out again.
When I hear you talk about this, it feels like that this is creating the network effect for data.
Exactly. I mean, and that's why I really only got into knowledge graphs heavy maybe 5 years ago. And once you start to see I mean, I'd done a good bit of database work and understanding. I mean, okay, you have sort of a table and you have a key to something else that lives somewhere else. And I started to look at knowledge graphs as a great way to have sort of dynamic references that we can invent new edges on the fly. I mean, you have all your data and you say, oh, well, this entity is actually, I mean, related to this other entity, and here's a new edge we're going to create. And in the SQL world, or kind of classic database world, updating the schema is always the biggest pain in the butt for everybody. And so schema migration and all that, and knowledge graphs are so much more dynamic, and they give you the ability to pivot on any entity and any edge in the system. And so we can invent new edges and then just kind of see what happens and say, oh, well, let's pivot on that edge and see what are all the things that relate to that. And that's where I love, I mean, I've been deep into it for about 5 or 6 years now. And it just, the ability to represent your data and that data model is really what's key for us. And we're learning things every day about it.
So you talked about building these edges in terms of the knowledge graph, but there's another sort of edge idea I want to get your opinion on, and this is the idea of edge computing. Are you familiar with this?
Yeah. Mm-hmm.
Could you tell me what it means to you?
I mean, to me, there is some device internet connected that lives typically on premise. We've talked to like food and beverage companies who have a manufacturing plant. They have a video camera on the site, the shop floor, and there's compute being done there. There's typically some internet connection back that some data is flowing back to the cloud, but it ends up being, I mean, kind of in the IoT world where there's like sensors and things like that. But I think it's a way to push compute closer to the source of data, and then take a derivative version of that data and push it back to the cloud for further processing.
I'm sorry to put you on the spot there, but I really appreciate that definition.
No, no, that's just the way I see it.
No, that's in line with my understanding of it as well. I first came into contact with this idea was in relation to satellite platforms, where the idea was, if we could compute up there, do compute up there in space, we could save a whole bunch of data being sent down to Earth, kind of thing. We could,
Mhm.
remove the bad stuff and only keep the good stuff. That's my very basic understanding of it. But I'm curious because, IoT, you mentioned that before, more and more sensors collecting more and more data. What do you think edge computing means for this idea of first order metadata, second order metadata, third order metadata? Are we going to see a dramatic shift there at some stage in terms of the kinds of metadata that are being created, at the source?
That's a great question. I hadn't thought too much about it, but it's an interesting. Like, I've talked to a few companies who have essentially live video capture. So they have basically little video boxes that are sitting connected to a camera, doing some kind of analysis on site. And what we've talked to them about is almost jumping past first order metadata because there's not really a file there. It's just a stream. And so you jump right into second order metadata where they're running ML on the device and giving us back object detection. And so we've been talking about a couple projects with partners that could be in that area. And we were just going to basically have them send us the object detection. And we would then import that into our system. And so we could still do things with it, but we wouldn't have the original files to start with. And so I think what you're going to see in edge computing is it almost ends up being more metadata management than file management because there isn't literally a file. And that's where, I mean, it definitely fits the model. And we have looked at, could they send us like an archive, like every night? Like if they're capturing it on site, could they just upload the last 24 hours or last 12 hours? And then we could kind of connect it up later and run more analysis on it is something we were looking at.
Do you think there's a danger there in like getting it wrong at the source and never being able to come back to it? Like if we're talking about metadata management as opposed to file data management?
Exactly. And I think that's what a lot of the folks that I've talked to, that continuous training of the models is important. So you're not going to train the model on the edge typically. And so you have to have some data flowing down to validate, is my model even good? And in some environments, I mean, you have people clicking like approve, reject, and they're saying, okay, this is good. But how do you know that? I mean, we had talked to a chicken manufacturer line, and how do you know if the video actually saw that the little hanger that the chicken was on was broken? And I mean, how do you know if that's good or bad? Like they can send an alert, but there has to be that closing the loop on that data. I think that's a tricky part, and I have talked to companies they have that continuous training, but I think how do you get that data back if it's sort of an approve reject is probably the trickiest part of it.
Yeah, that would be a really difficult problem to solve. I wonder if tagging it would just be enough, and using it as a filtering mechanism at the source, where that first sort of stage of filtering was done for you, where things where the model was in doubt, and just tag everything. Like a human needs to look at all of this stuff, please.
Yeah, I mean, or even just have a big red button or something that the person at the plant could say, oh, I mean, there was a problem. At least it gives a signal back to them to go look at the data later. It may be something like that.
So you've given a bunch of different examples of projects that you've been involved with or discussed with other organizations. Who typically comes to you? Like, who comes to you and says, look, we've got all this unstructured data. Can you structure it for us?
Yeah, I mean, we're still early. I mean, we just launched about a month ago, so we're kind of more the opposite. We're going out trying to find people, but at trade shows have been really useful. We've done a couple conferences where people come up to the booth, and we've gotten some really interesting use cases. I mean, one in the geospatial area was an aerial survey company, and they typically, I mean, they fly over. They're actually very savvy around like photogrammetry and the data capture they're doing, but they're poor at data management. I mean, they're keeping their data on SharePoint. They're not cloud native yet. They don't really have a search angle to what they're doing. And the common thread we tend to hear is people look at their data in almost with blinders on. They may look at that day's data or that week's data, but once it starts to age out a little bit, it goes dark. And that kind of sort of dark data concept is something that is starting to be an industry term. But it's once, I mean, they've captured the data, but they're not making good use of it. And so we provide a way to look across like years of data and start to see trends or commonality. And that's really where the interest lies from a lot of the folks we've talked to. And I mean, sort of bridging the gap in their kind of daily workflows to historical analytics and things like that.
That's really interesting. So actually, a lot of the value is in the archive, in the stuff that's old, making the connections between that. So what did it look like in the past? What does it look like now? How do these things relate back in time?
Yeah, I mean, we always talk about everything is indexed geospatially and temporally, and then via like a tagging taxonomy, and that's where we start. So it's how we generate those tags, or we've even generalized that to what we call observations now. And so an observation can be of a person, a place, or a real world asset, or it could just be a simple tag, just a generic word or phrase. And so everything maps back to these observations in our system. And those observations can come from document analysis, they can come from audio transcription or computer vision. But once you have that data, that's where it gets really interesting. And then you can start to look at like, hey, I've seen these observations this month. We start to see like a trend analysis of these observations ramping up, and then providing alerting. And that's typically what people want. They want data triage. they either want to do data discovery that's more user directed, or they want kind of data triage and alerting that's more automated. That's usually what the two things that it falls into. That's really where it starts is I put a massive data in the system. Let's see what's there. Like I just was doing a test last night. I uploaded, I don't know, a couple thousand images from different drone data that I had and didn't realize some of the data was actually in Europe. And I mean, if you're just looking at files that are from a DJI drone that are like DJI underscore like 1234, there's no indexing on it. I mean, there's no obvious metadata. But once you process it through a system like ours, you can see when it was done, related things that you were taken around that time frame, both time based and geospatially, as well as sort of clustering of is it, what kind of data is this? Is this outdoor data? Is it more commercial building data? All that kind of stuff is so non-obvious. Just when you're just looking at a folder on S3.
Could you imagine a world where, like, I came to you with some data, lots of sort of different kinds of data, and said, please, run this through your system, create metadata around it, make it searchable, make it discoverable, let me know what's going on with my data right here now, and what's happened in the past, and then expose that as some kind of maybe a web catalog service or something like that, something that was searchable on the web, where I can expose it to the public and say, here, this is all the data we've got. We've created metadata around it. If you're looking for data, look in here.
Exactly. Yeah. It's actually something we're thinking about, and we're going to be opening up our APIs. So if you're a customer of ours, you can essentially search the data, get access to it. We are thinking about putting up a public catalog of like, here's basically you can, publish data into it and have that kind of site. But also, I think you had passed me on to the Stack format or API, and it's kind of like we've done some similar things with image tiling services and things, and it would be a great fit. Really to kind of expose this as a public catalog. And we've actually talked to a group that does geospatial work in Los Angeles. And they had ideas of, well, what if all just people are posting pictures of like potholes and things like that. And it could be even like a crowdsource thing that what if there was some app that they could publish into our knowledge graph and then actually, have public access to it. And so it's something we're thinking about. We don't have a public angle to what we're doing yet. It wouldn't be that hard to expose, but it could do some really interesting things that way.
The way I understand it, up until now, we've been talking about like a database or a S3 bucket full of files, full, blob storage somewhere where you put your, point at that, get access to it somehow, ingest it, and then create these knowledge graphs and do all the things we've been talking about. Is there a world where I could take a service like yours and point it at an API and say, can you just poll that API and can you do that and build like a knowledge graph around what was that and like tell me new things about that data?
Well, that's where the funny thing is, that's where it all started. So I have it, we have this concept of a feed. And so it's essentially it's based kind of on the RSS feed concept where you can have any API that we can read. It could be an RSS feed. It could be, what other ones do I have? Spotify. I had music ones because this is where it kind of started, and I could get like the new releases, and it chops it up into like posts, kind of like RSS posts, and we can process that through the system. So essentially, we have this polling model or this poll model that we have any API out there we can kind of convert into our common data model and kind of have a continuous feed of data. So we could talk to a SQL database and look for new rows and basically generate events and these posts in our system that can be processed. We just added email support recently, but in a file-based world. So we could drop in like a MSG file or an email file or even a PST file, and we'd like an Outlook file, we crack it open and do document analysis and everything. But I could see a world where we're listening to the Google Mail API or the Microsoft Graph API and things like that. That's really, conceptually right in line and probably wouldn't take very long to integrate.
That's really interesting. A lot of those examples for me, they were, at least in my mind, an example of a feed that's constantly updating. So you could, like you said, you could sit and listen to that feed. I was thinking more about some geospatial APIs there. You show up with a geography and say, well, show me everything within this polygon, in this geographic area, and make a request based on that. And I'm wondering if you could do something like that. If you knew the bounding box of the API and just started polling it constantly, and building like this knowledge graph around the stuff that you're finding, That would be amazing.
We have a concept of places. So when you drop in an Esri shapefile into our system, so we ingest the file, we extract, basically convert it to GeoJSON internally, so we get a geofence, and then we what we call promote it to a place entity, and so it creates a place in the graph that becomes more searchable. Kind of, it's like a top level entity in our graph, but we also do data enrichment on that. So I go and I look and I call the Google Places API and I try and map that to, okay, like, is there any other metadata essentially I can get around that place? But we could also do, I mean, I've talked to Nearmap, I've talked to a couple other satellite services. We could go enrich and like go get me the latest satellite data for that region and layer that in. That, because of the way we have our eventing model, we could essentially, we now support webhooks. So when anything happens to the system, like an entity is created or a tag is added, we can call a webhook. And so that's an area where, for now, anybody could build a data enrichment where they could call some other API and then call back to us to inject data back into the graph. But we're also looking at other ways where we can basically just do that in a box. I mean, where we could add that as a feature for a customer to say, hey, for any Esri shapefile you put in here, go get me the latest satellite data from this service, and we could just have that as an option.
But how do you know where to stop with this? Because I think at some stage people might feel like they're drowning in data. How do you know? And you might cross a threshold where, like, the return on an investment is massive. You know, it just goes up and to the right, and then it dips off. How do you know where to stop these spiders? How do you know when the knowledge graph is like, okay, that's enough to complete this task or for what we're doing today?
Yeah, I mean, that logic is the tricky part. I have in the development, I have created bugs where I kind of created an infinite loop of spidering. So there's definitely a risk there. I think at some point you have to kind of see. I think what we did is, if we start to enrich and we're not making any changes, if we're kind of seeing like, okay, I'm getting more data, but it's literally the same data that was already there, I would start to cut off the spidering at that point. And so it's that is really one of the big problems, though, because you can, I mean, spend a lot of money in calling out to other APIs and doing enrichment that may never be needed. So a lot of the logic kind of around that is really around how far to spider. But yeah, it's I mean, that part of it is, data enrichment is almost boundless, and what we're doing is almost boundless, and really it comes down to the customers.
So this is, it sounds incredible, and I've learned a ton just through this conversation alone. But I'm wondering, like, who is this not for? So it sounds like a lot of people could use it, but if you had to say, point at an organization or a particular industry or someone, who is this? Who's not? Who are you not building this for? Who shouldn't be considering this?
And I think a lot is, it's a difference between the technology and the company. I mean, the technology is really broad. And that's why, I mean, it started as a podcast discovery. I mean, it could be used for the media entertainment side, it could be used for a lot of different things. But as a company, what we've done is we've focused the technology for anything that essentially we call it extracting insights from unstructured data that is perceiving real world assets. So we've constrained it to, there's some geospatial element. You're typically, the data is about something in the real world. So, I mean, we've had some interest from like healthcare and different medical research and things like that, for maybe like scanning images of x-rays and stuff like that. And we just haven't really gone down that road because there's no geospatial angle to it. There's a temporal angle and there's a lot of overlap. There's a lot of data there, but it's just not our sweet spot. And so we're trying to focus on carving out something where there is, I mean, that geospatial angle.
Is that because of the extra context you're going to get with the geospatial data?
Yeah, and I mean, it's not even a technology problem. It's just I mean, we can't really boil the ocean and do everything problem. And just as a small company, we got to have some focus. But I think it's also, what I'm really excited about the contextualization is being able to link. I mean, it is a little bit of kind of the digital twin concept of, I mean, where physical assets and entities exist in the real world. But for us, if we can map simply by uploading a photo, we can know what piece of equipment or pieces of equipment are in that photo, and we can give you almost like a little heads up display on, here's the current sensor data from that conveyor belt, here's the sound vibrations, the last 5 sound recordings of vibration of that, literally by just taking a picture. That's what we really want to get to, and we're not all the way there, but the fact of, if we can reverse engineer kind of what you're looking at in 3D, kind of map back to looking that up in a database, getting that data from some other, maybe a SQL database or a time series database, and then start to look at contextualizing that across weather. I mean, oh, we see water pooling. Oh, but they just rained 3 days ago, so that's not a problem. Trying to pull in other data sources. That's our long-term vision. I mean, it's really this kind of knowledge hub for the real world, in a business case, enterprise and business sense, essentially.
Well, when you think about the big drivers of unstructured data today, what do you think about? Do you think about satellite data? Do you think about imaging? Do you think about IoT? Where do you go?
Yeah, I think. I mean, we typically look at the three main sources of data for imaging and video we get, and even what generates 3D is it's drones, robots, or mobile phones. So it'd be like a spot robot, a drone, or just somebody with an iPhone walking around. Those are like the three main sources of data that we get, other than documentation, or CAD drawings and things like that. So, but typically those are data about your real world assets. And so the documents are like maintenance reports, or there might be a Zoom meeting that was recorded about, say, an inspection going on. And so those are kind of providing context, but the image, we tend to be more imagery heavy, and just because that's a lot of where the volume of data is. But more and more, we want to pull in other data formats that kind of relate to that.
If you get to the stage where you can join like as built documentation, those PDF documentation that all engineers love of CAD files of structures in the real world with other data, like current data about those, then you are on a gold mine, my friend.
I hope so. I mean, that's what we're trying to get to. I mean, and from the folks we've talked to, I mean, essentially they just have a massive data, and they just want kind of, and we talked to an oil and gas customer who said, look, we don't want Google search. Like, just searching file names isn't enough. Searching full text isn't enough. You essentially want like a semantic search, and that's what we're creating, is a way to search across the relationships that we've gleaned from their data. And
Okay,
yeah,
sorry to interrupt, but
yeah,
that's
go
a
for it.
brilliant point. Like, are you not afraid that Google's going to do this? I mean, what is their whole mission, to make everything searchable or index everything in the world? Like, are they competition for you?
In a pattern sense, I mean, what we're doing is a lot like Google Knowledge Graph, but they're so consumer focused. I would be more concerned about like a Palantir or a C3 or Cognite or any of these companies that are focused on kind of these real world things. I mean, those are more the people we would see ourselves pairing up against. But I think there's unique things that we do by leaning in more on the unstructured data. We're not as vertical. So what we also want to engage with is ISVs and companies to build companies on top of our platform. So our goal is to be more of a Snowflake or a Databricks. So it's more of a data platform that people can build around and on top of. In addition, I mean, you can use us kind of out of the box as well, but we really see us kind of doing the heavy lifting to get some really interesting vertical applications, like property inspection is one. I mean, taking iPhone photos of rental apartments and pulling in all the data around that, and automatically kind of creating a representation of, oh, like, when did this sink break? I mean, was this sink broken in the last inspection? And I mean, do you track maybe we could track the emails about it with the renter and things like that. That's where I think there's some really interesting vertical products that could be even built on top of our technology.
Well, I said it before, I've learned a ton in this conversation. I really appreciate it. I think probably now is a good time to sort of wind things down a little bit. But part of me is super excited, fascinated. Another part of me is a little bit terrified because it feels like everything is going to be linked to everything else at some stage. And personally, I just don't know if I'm ready for it yet.
It's interesting. I mean, I know, I mean, we're not really going down that kind of intelligence route. I mean, I think a lot of these concepts are being done in the true like NSA type Palantir intelligence community. And I've sometimes jokingly called us kind of Palantir light, because there's a lot of, I mean, I love the concept of how they approach like their knowledge graph and things like that. And I totally understand why it's like multi-million dollar contracts and the value you can get out of it. But I think there's a smaller swath of that you can take in kind of a no code environment for just normal business. I mean, it could be, I mean, I don't know, we've like a paving company that just wants to track each of their jobs and map that against their work orders and their emails and their meetings. So we really see it can go all the way from SMB up to kind of mid enterprise. I don't know if we'll go. I don't anticipate us going for like the massive enterprise deals. Just we're really focused a bit more on a notch below that and downward.
Well, I am going to be following along because I think this sounds really, really interesting. And if there's people out there listening, where can they go to follow along? Where can they go to learn about this, to catch up, to see it in action?
Yeah, for sure. So we are launched on the Azure Marketplace now. Our website is unstruct.com. A better one's coming out soon. It's still a bit of a placeholder. And then just LinkedIn. I mean, it's the best place to watch the company and connect with myself. Love to, if anybody has problems in this space, I'd love to talk to them. Just love talking to people about the data they have, the problems they're seeing, and just that discovery part of it is super fun.
Well, I'm going to keep my eye out. If I meet anyone in my travels, I'll definitely make some introductions.
Appreciate it so much.
Thanks very much for your time, Kirk. I've really enjoyed this conversation.
Same here.
Well, I really hope you enjoyed that episode with Kirk. I'll put links in the show notes to where you can catch up with him, where you can reach out to him if you're interested in perhaps working with Unstructured Data or finding out more about what they do. And of course, I would love to hear from you too. You can connect with me on Twitter at Mapscaping, or there'll be links to my LinkedIn profile and to our website, mapscaping.com, in the show notes of this episode. So feel free to reach out. I would love to hear from you. Okay, that's it for me. That's it for another episode of the Mapscaping podcast. I'll be back again next week. We'll talk then. Bye.